Alright, so let's talk about elephants. Let's be honest, elephants are one of the coolest animals we have. Who's not in awe when they see an elephant? But currently we only have 2 species of about 180 proboscideans which roamed our Earth. Now proboscideans are basically just mammals that have long noses and flat feet. The story of these gentle giants goes back all the way to the end Cretaceous start Paleogene extinction event, aka the end of the dinosaurs. So after a mass extinction about 65 million years ago, in which the Earth was rid of most of its biomass because the dinosaurs died and so did most of the plants that they lived with. The first time proboscideans do show up in the fossil record is in northern Morocco about 58 million years ago. And what we do find is not what you see today in our gentle giants. They're much smaller pig-like animals which are less than 1 meter tall. An example of this are things like Phosphotherium and Erytherium. These pig-like animals had small proboscis and maybe a few elongated teeth which could serve as tusks, but nothing like today. Now fast forward to the Eocene and the world enters a warming phase. Even the Arctic Circle is seen forest and most of the Earth is rainforest and swamps. And this is where Barytherium comes up. It's a hippo-like animal which has 8 tusks, 4 on the top, 4 on the bottom, and this allows it to eat through hardy plants in swamps. It's also potentially amphibious and has the ability to move through lowland bodies of water. See, the challenge that was faced up until now was that Africa remained mainly an island continent at the time. It wasn't connected to any other part of the world, and this is where most of the proboscidean evolution was happening, so it was restricted to this landmass. Until at the end of the Eocene, when Africa suddenly clashes with Eurasia. This, combined with the Earth entering a cooling phase and the rise of land bridges between continents, allowed proboscidean evolution to go wild. The first of these evolutionary products that we'll explore is Deinotherium. Now Deinotherium did evolve in Africa but used the opening of this land bridge to move into Asia and dominated in the forests and tropical climates of particularly Southeast Asia. This was due to its lophodont dentition which allowed it to crush plants and eat much harder plants. But also it had other adaptations like flexible limbs which allowed it to live a more cursorial lifestyle, meaning it could just run around better. This initially led the first scientists which came across these fossils to think that it was some sort of link between elephants and also things like sloths and maybe even tapirs, but this has turned out not to be the case. Now while land bridges were forming across Africa and Asia, the cooling of the Earth also meant that there were land bridges forming between Eurasia and North America, mainly in the Bering Strait. And some proboscidean animals took advantage of crossing this land bridge, and the most famous of these is the mastodons. Mastodons developed a few unique features, such as zygodont dentition, which is particularly useful when you need to shear through plants in quite dense vegetation environments. They also developed a set of almost straight, like parallel tusks, which are very unique in the proboscidean lineage. It was very advantageous in North and Central America that was a bit warmer than the rest of the world at this time, meaning that they could almost live semi-aquatic lifestyles and preferred places like wetlands and forests. By far the most diverse proboscideans during this era are the ambelodons. Now the ambelodons are also known as shovel tuskers because they have this weird look whereby they have 2 upper lips and one of the lower lips has got incisors on them. The most famous of these that you've seen maybe on a couple of drawings is Platybelodon. And these were so diverse because of their simple structure. The structure was quite unique in that it had multiple usages. They could either use this in swamp areas to pick up plants or in drier areas in order to shear bark and still get food. The most interesting proboscidean to look at this time is the Gomphotheres. Now the Gomphotheres, although originating somewhere in Africa, by the end of the Pleistocene had made it all the way to South America. And they had a few evolutionary changes which resemble modern elephants. One of them is losing any form of tusks on the lower jaw and only having tusks on the upper jaw like modern elephants do. They also evolved to become much more generalist and flexible feeders. See, as the Earth was cooling down, grassland started to dominate where forests once did, and the ability to switch between browsing and grazing became quite an important evolutionary skill. During the start of the Pleistocene, or the Ice Age, the proboscideans are quite a widespread lineage, but the biggest developments happen within the Elephantidae family, or what we know as elephants today, elephants and mammoths. Now both elephants, Loxodonta, and mammoths inhabit Africa at the time. Now while in Africa, these 2 genuses seem to have avoided competition. This is because most fossil sites almost never show their fossils together, and where their fossils do appear together, it seems that Loxodonta took over areas after Elephas had already left and migrated. The Elephas lineage then spreads into Eurasia, and this is where further speciation happens. Towards the southern eastern parts of the continent, it is much warmer, and therefore we see the emergence of Asian elephants, much more suited to more lush and more tropical environments. But towards the western and northern parts of the continent, the cold of Siberia and North America takes precedence, and we see the emergence of woolly mammoths. These famous giants were just slightly taller than the famous African elephants of today, and this was due to adaptations needed to live in such cold environments, such as thick fur, a lot more fat, and larger bone structure. At the end of the Pleistocene, a couple factors then start to come into play. The first of the major ones is the arrival of modern humans. With all the beautiful qualities that mammoths have to survive the cold, also made them good prey for humans because they had lots of meat and also had a lot of material to keep people warm. But most likely, the main culprit for the extinctions of mammoths, mastodons, and other proboscideans at the time is the changing climate. The Earth then goes out of an ice age at the end of the Pleistocene and starts to warm up. This is disadvantageous, especially in North America, where climate change seems to have happened more rapidly. And that brings us to the modern day, where we have a single family of proboscidean that has survived all these anthropological and climatic changes. This is the Elephantidae family, and it's split into two main genuses, Loxodonta, also known as the African elephant, and Elephas, also known as the Asian elephant. Within these, there is only one species of Asian elephant, and it's split into many subspecies which have isolated populations, such as the Sri Lankan elephant, Bornean pygmy elephant, and Indian elephant. The African elephant, however, is split into two distinct species. The savanna elephant, which lives towards the southern parts of Africa, and the forest elephant, living more towards the central and western parts of Africa. While there are small changes, they mainly have the same features. Particularly African and Asian elephants is how they interact with humans, because this is a major driver in their survival for the future, as human-elephant conflicts are at an all-time high. Asian elephants actually lead the way when it comes to human-elephant interactions. A decent percentage of their population has actually been domesticated by humans and used in many industries such as farming, manufacturing, and tourism. But it is more complex than that, because Asia is also the most populated part of our planet, meaning that even wild populations interact with humans on a daily basis, and this leads to a lot of potential problems as they end up destroying crops, raiding houses, and also just being used as meat. The African elephant, on the other hand, shows a much lower potential to be domesticated. Yes, there are certain places where it happens, but usually it's over a longer period of time, and they're much more resilient to any form of domestication. But because they are so much larger in number and larger in nature, they need larger home ranges to exist, and that brings them into contact with humans a lot of the time. Countries such as Botswana and Namibia are currently struggling to control the balance between the human and elephant populations. The main reason for the escalating human-elephant conflicts is that elephants require large home ranges and they are destructive by nature. Elephants are what we call ecosystem engineers. Their destructive nature allows ecosystems to regenerate, and they are a huge driver in pollination. However, these qualities are not exactly advantageous when you have anthropological changes where people want to keep the environment stable and want to have certain goals from the environment, such as farming and housing, which elephants are not necessarily always accustomed to. The complexity around human-elephant interactions deserves a whole video on its own, but I hope that this video on proboscideans just gave you an idea into the long history that comes to the only proboscidean that shares our world today. If you love biology, paleontology, zoology, ecology, or anything with nature, Odyssey Orbis is going to be the place for that in 2025. And if you want just a sample size of a bit more of what we do here, you can check out this video up here on the sociality in cats.